And welcome to the virtual JBoss user group. Today we've got Alex Justin here talking about the CapeDwarf project. And today he's going to talk us through how to deploy Google App Engine code to the Wildfly Application Server. So hi Alex, good to see you.
Hi Paul, good to see you as well.
All right. So if you could maybe introduce yourself, that would be great.
My name is Alex Justin. I come from Slovenia and I'm a remotee. I'm a software engineer for Red Hat. I work on a CapeDwarf project and cloud enablement. So that's OpenShift and all middleware, JBoss middleware related to the cloud.
Great, thank you. Okay, so do you want to start with your slides? That'll be good.
Oh yeah. Let me start with the slides. Let's just switch on to the screen sharing. Like this. Okay, share. Is it okay?
Yeah, that's good.
All right. Yeah, as you mentioned, we're going to talk about deploying Google App Engine apps into JBoss environment with the help of CapeDwarf project. So basically, it's like a topic of how you implement something as your own Google App Engine. A bit of history, like I think with almost every project, it comes down to a bit of sandboxing, playing with some of the stuff, and then realizing that could be turned into a real project. So that happened the same in the case of CapeDwarf. I was basically playing with the Google App Engine, the real Google App Engine, and with some Android app. And being an enterprise Java developer, not a user, but basically being involved with JBoss Application Server and the Java EE spec for a long time. It's all about the API, and the same way here with Google App Engine, right? It's about the API. And I was thinking about I can actually implement some of the stuff, some of the Google App Engine API. I started off with a first, I was using the Datastore API. If I can pull that off, I think I can pull all the other parts of the API as well. And yeah, this is how it evolved. We started off with a prototype, it was working, and then we moved on to other aspects of the API. And of course, we set up some goals. Some initial goals on what we want to achieve, and basically as simple as it is, so you take an existing Google App Engine app and you just drop it into Wildfly, and it should just work, right? You don't have to change any of the code, any custom stuff and so on. You just drop it into Wildfly and it should work. It should just deploy, and then when you're using the code against Google App Engine API, it should just work. Of course, it creates you a no-vendor lock-in. It means you can, at any point, move from Google App Engine into CapeDwarf and vice versa, right? And of course, when I was, for example, part of the CapeDwarf came from the frustration of me using the Google App Engine SDK, because the actual implementation is quite a bit of a mock. So I started off with using the SDK, and when I moved my pet project onto the app spot, it was like a completely different stuff, right? It was the stuff that used to work for me on the SDK was completely broken on app spot, and I was thinking like I can probably do a better SDK, and that's what CapeDwarf probably. I think that what CapeDwarf actually is, and of course with the SDK, you don't have any cluster; it's just like one node. So, but with CapeDwarf, of course, you can do even cluster debugging and testing. And with that mentioned, we just recently had a talk here in Ljubljana, and there were people from one company that does, I don't know, the Talking Tom on the Android app and iPhone app and so on, one of the most successful mobile apps, and they're based in Slovenia, and they're using, and they had a big bug about some memory leakage, and they couldn't find it on the app store. It was like too hard to debug, right? And they couldn't debug it on SDK because it doesn't do what they want, like wasn't burdened enough. And then they used CapeDwarf, and they were easily able to find what was wrong. So it's quite easy to debug in a cluster, right? You can just connect to the instances and you're fine. And of course, testing is much easier with all the tools that we have around Wildfly and so on. With that, of course, with OpenShift that we have, you can also create an on-premise cloud with CapeDwarf, meaning you can have your own Google App Engine in your own private cloud. And all the pieces, when we set out to do, like all the pieces, I'm not saying they're like completely perfect, right? But they are designed to scale. So all the small pieces that we used, we always thought about scaling, right? So you could eventually scale up CapeDwarf to whatever you want with the components that are inside. We didn't reinvent the wheel, we just used what was out there, right? A bit of agenda. So what exactly is Google App Engine? Since you're probably here, you do know what it is. I'll go into a bit more details. What's JBoss CapeDwarf? How do the two fit together, and so on. Since this is like a technical talk that Paul wants me to do, right? We'll go into some of the dirty details, not too much, right? But at least what we can explain in an hour span. I'll try to do a small demo just to see what it looks like to deploy a simple app. And if you have some time left, I can do the questions and answers from the IRC and so on. I already introduced myself, so we won't like the bottom line. I consider myself an old school JBossian, and I was here from 2006. I used to work on the microcontainer, which was a kernel of JBoss Application Server at that time. I moved on to CDI, Ceylon, and I do a bunch of other stuff as well. So what is Google App Engine, right? As they stated on their page, it's like a App Engine lets you run web applications on Google infrastructure, and of course it's easy. You don't have to do any of the system administration. You can scale your traffic. You can poke data storage. You can store large sections of data or binary data and so on. And of course, as it said, you just upload your application and you're ready to serve, like in like a minute or so, right? So it's really, really easy. And they are evolving. They're putting a lot of effort into it and so on. So it evolves quite nicely. But at the end, of course, for us, it's all about services and the API and its API, right? That's what we care about, and that's what they want. And the API, as it was always designed to be in the cloud. So that's like a different approach to what we used to do with the enterprise Java, which is still more of like a couple of nodes in a cluster based, where this API it's been designed from ground up to be run in a cloud. Let's move on to CapeDwarf. It's an open source implementation of the Google App Engine API. There are pieces of real Google App Engine implementation as well that are open to it, but that's mostly like a facade code that delegates the real work into the Google backend, so you don't actually see much. But in our case, you see all the details of how we approached, and it's of course as Red Hat, it's all about open source, and it's all open source on GitHub. For the users, of course, you care about the API, not the actual implementation. We go about the Java docs and the stuff that the API provides, the documentation and so on, and we follow it closely and try to implement as it's specified, right? But you as a user, you don't care about the implementation. You should just care about the API as a proper approach to programming, right? It's written on top of JBoss. As I already mentioned, we don't try to reinvent the wheel where it's not needed. And it's written on top of JBoss and other open source frameworks, libraries. Like InfiniSpan is a big part of it, Hibernate Search, HornetQ, Lucene, Picket-Link, JGroups, and so on. We just reuse what's already there. And the nice thing, a lot of this stuff is already in Wildfly, and we just probably add a few modules of our own or some of the libraries of our own, and that's it. It runs as a Wildfly subsystem extension. That's how you extend currently Wildfly. And because that's basically that is Wildfly with additional stuff on top, you already get what Wildfly provides. That's management, clustering, security, and so on. So what you get in Wildfly, you get in CapeDwarf. It's super easy to set up. It's just unzip and run, as it was always with JBoss Application Server and Wildfly. You get we bundle it properly together, put it on the download page, and you pull down a zip distribution and unzip it, and you're ready to run, right? Just unzip, go to the /bin directory, and you run it. It's also trivial to set up a cluster with multicasting and so on, or you can of course do some custom stuff around it, but by default, if it's on the same network, it does a multicast and it already finds different nodes, and you create a cluster. That's the normal stuff from Wildfly, right? It's nothing new what we do in CapeDwarf. And it's also a nice way to debug, like I already mentioned, scalable apps. Since of course we're talking about the cloud, the API that runs in the cloud, and Red Hat has its own platform as a service called OpenShift. Of course, it's already integrated into OpenShift. With OpenShift moving quite fast from version 1 to version 2 and now to version 3, I must admit we are a bit lacking behind with the current cartridge, which is from like a notion of OpenShift version 2. With OpenShift version 3, we're moving into Kubernetes and Docker. So basically what we need, we'll provide a proper Docker image that's going to be used in the OpenShift version 3, and that's it. So, but those are the details of the OpenShift. Or of course, you could use the same image on your own, because it's going to be in a public Docker hub, which you can use. And of course, OpenShift is going to use the same image. Or I mean, it probably could be a bit tweaked to fit OpenShift even nicer with some of the details of OpenShift, but that's mainly it. And as I already said, you can get an on-premise cloud environment with because you have an OpenShift that you can set up privately, right? With setting up OpenShift privately, you can then get CapeDwarf out of the box for free. It's 100% pure Java, so it's all written in Java. There's no sort of funky backend in the back or whatever. It's all in Java, and it's all on GitHub. This is the organization's link, and it's not just one repository, so like more sub repositories in that organization. We have a Cape, like the name's a bit odd, like a CapeDwarf Blue, which is where the API implementation lives. So we have CapeDwarf JBoss AS, which is where the integration with Wildfly lives, because we need some pieces, integrate some of the pieces. That's the subsystem and extension part where the JBoss integration code lives. And of course, those two pieces need to also communicate with each other cleanly. So we have something called CapeDwarf Shared. So it's like a shared library between the Blue and the JBoss AS. And for example, in order to properly test all of this stuff, we have something called CapeDwarf Test Suite with all the possible tests that are out there. So we build a fresh instance of CapeDwarf and test it with all the tests that are out there. For that, we created some of the, I'll also mention it later on, but if you're familiar with Archelion and Shrinkwrap, we added some of the custom stuff on top of that to accommodate all the tests that are possible. So we do care a lot about the testing, and it's also part of the slides, so I'll talk about that a bit more. This is the current API matrix. So you have, it's like the API plus extensions to it. So if it's like a check mark, it means that we do it pretty good, or I won't say like, I wouldn't bet my hand is like 100%, but we try to do as much as possible. So, and there are tests to prove it and so on. If there's like a flower, of course, that means that we are halfway there. There are, for example, some of the stuff, if you look into the XMPP, of course, we don't have GTalk in the back, so we cannot do full GTalk integration or with the XMPP API. But of course, you could set up your own XMPP server and connect to it and so on. So the pieces are there, but it's not, of course, it's never going to be GTalk. And for example, the admin console, we don't have as much things that you can do. It's more of like a SDK admin console with some of the extensions, some of the custom pieces into it. And of course, if you look at mail, of course, we don't have Gmail in the back. We have to set up your own mail server or connect a running mail server and basically pull down emails and handle them as you handle them in Google App Engine API and so on. But of course, there's no Gmail in the back. But of course, there are other things that we also support, like cron jobs, Google App Engine modules, sockets, JPA, JDO. Although they prefer a different OEM. What's it called? Okay, let me look at it afterwards. We do support they have a library for doing a map reduce on top of Google App Engine API. We support that as well, like a warm-up request, endpoints, and of course SQL and so on. Okay, multi-tenancy, there are pieces that we still need to implement, but the rest of the API is pretty much there. It's solid. It's been around for a year or so in being pretty solid state. We do releases as often as possible. When we actually, now it's in the stage where we mostly just maintain the code, because the Google itself doesn't add any new APIs. So we don't add any APIs, and the stuff that we have is pretty solid. Okay, I mentioned testing. So how do we know that CapeDwarf actually works? I can talk about it all as much as I want, but of course you need to see it on your own. You have to have solid proof that it works, and this is on the next slide, right? Once we started off with the project, of course, at one point when we had something that was working good enough, we approached Google with it. We were actually invited to San Francisco to discuss it and to show it and so on. And they were quite impressed with what we had, right? It's like not that you get every day that you have some crazy people from Slovenia implementing your flagship platform as a service. And of course, one of the questions that they had was, one of the first questions, how do you know that the stuff works? And what we did was, we, of course, with every implementation that we created, we also created, it's like most like a 50-50. Implementation, 50%, and the tests are 50%, sort of, probably more implementation now than tests, but yeah, we did put a lot of effort into testing. And of course, we said, like, we have this, we showed the CapeDwarf test suite, where we had our own custom stuff to basically be able to test all the stuff through Herculean and shrink wrap. And of course, then my question was, how do you test your stuff? Would it be possible for us to get our hands on your tests and see how much of those we pass, right? And of course, they had something, it was interesting, they actually had something similar to what we have. But of course, it was like too much tied into their own environment, so it wasn't as easy to just get it out and test it against a running instance of CapeDwarf. So what we did, we decided on collaboration, and we moved under the same umbrella, and that umbrella is Google App Engine TCK, Technology Compatibility Kit. It's like it was like a joint effort, and still is a joint effort from Google and Red Hat. So what we did is, like, we moved our own tests, what we had, into the TCK, and they were slowly porting their tests also into the TCK. Also, for example, for the Datastore, which is probably the most intense API, they had this data nucleus, which is a JPA implementation. They had a bunch of data nucleus tests, which were running against JPA, and JPA was mapped on top of Datastore API. So through a couple of layers, they were testing intensely their Datastore API. And what I did was I sort of bytecode manipulated a bit those tests, because they were running like locally or on a different way against their Datastore, and I was bytecode manipulated those tests to see how much our Datastore works. And the tests were quite good, so we knew we were on the right path of doing things. And once Google started pouring their tests into the TCK, and we started putting those tests into the TCK, we had a really clear picture of where we stand with regard how properly we implemented the API. You can find, there's like a page, you can see the link here. It's like appengine-tck.org. And there's more. There's like all the tests. You have the link to the whole TCK is open sourced. It's also on GitHub. It's under Google Cloud Platform organization, which is run by Google, of course, and it's all open source. So you get your hands on all the tests that are part of the TCK and even more. And just follow up this link, and you'll see we have also like a nice representation, like a graph representation of how much tests we pass, because we don't pass all of the tests. There are some details where we aren't able to actually implement that functionality, some sort of strange indexing stuff, because it doesn't exist in the Lucene itself, but they are able to support it in their own Google backend, right? And we show graph representation of how much we pass, how much the SDK passes. Unfortunately, they don't share the AppSpot information publicly. And as I said, you have links to the GitHub repository of the tests. There's like 1,000+ API tests, and we have additional tests for endpoints, data nucleus, MapReduce, modules, concurrency, through Byteman, and so on. And just recently I added the G Cloud support, which is for the managed and custom runtimes. So for example, if you're creating your own custom runtime, which sort of encapsulates the context for being able to invoke Google App Engine API through your custom runtime, you could easily use the same tests, right? You just need to you just need to set up your own G Cloud environment with your custom runtime and point those TCK tests along with the G Cloud profile, and you'll be able to run the same set of TCK tests against your own custom runtime. It's all the TCK. It runs on Maven. It's JUnit, Archillion, and Shrinkwrap based. Archillion and Shrinkwrap are nice JBoss projects to be able to test various things independently of the runtime that you're using, like a container abstraction and binary abstraction, which is Shrinkwrap. So you can nicely, instead of, I don't know, we were used to creating all deployments through Ant or Maven sort of assemblies and so on. So no more, you just do it through Shrinkwrap and programmatically create deployments and push them into Archillion, and Archillion abstracts away the containers, and you're able to run the same set of tests against different runtimes, right? In our case, we have the same set of tests running against CapeDwarf, SDK, AppSpot, AppScale, and so on, right? We have a nice test coverage report, which I'll show in the next slide. I shall switch between the presentation and the browser. It's easy to add new containers runtimes. As I said, we have CapeDwarf, AppSpot, SDK, AppScale. If you have your own, like I said, custom runtime, just use it and so on. If somebody else would to implement their own Google App Engine API, they could just add a new container support and will be also able to run the TCK, the same set of TCK tests against their own implementation. We use all the GitHub community power, so just if we have pull requests, we can review the code and so on. Okay, the stuff that I promised, let me just switch. So here it is. For example, this is what we do is we also generate, we go and we inspect the bytecode of those tests to see where certain API class is used. For example, we're talking here, as hopefully you can see, we're talking about the App Identity Service, right? That's part of the API. That's the App Identity Service API. And for example, we see where in the code, that's the method. Okay, get access token, get access token. It takes an iterable and so on. But now we're, click something. Okay, if I click on this link, it redirects me to a Java doc. Okay, let me click. Okay, we were redirected to a Java doc. I go back. But if I click on this link, where it shows, for example, this method is used in this and this test. It's used in this and this test. with this name. It's an app identity service test class with test get class access token with scope. If I click on this link, it redirects me directly to a GitHub page and points out the line, like a service code of the test on GitHub. It points me the line where this method is used, right? So not only that you see if we are actually covering all the methods and how much we cover them and so on, you can even see best practices. We try to write those tests in a fashion that do resemble how the API should be used, right? Of course, we cannot always do super properly, but we do try, because we have to somehow mock some of the stuff, right? But we do try to use it and create those tests so that they properly represent how the API should be used. And if you go to the TCK page, follow those coverage reports, you can drill down into the source code usage of those methods. Okay, let me switch back to the presentation. So for example, okay, you find a bug, or you think it's a bug, right, in the App Engine. You are just going through, you have your own Google App Engine app, or CapeDwarf app, or whatever, right, or okay, Google App Engine app. And you see some of the stuff doesn't behave as you thought it behaves. You might find a bug, you might misunderstand how it's used, you might, I don't know, whatever. And it's pretty easy. Just, for example, of course, first, you look it up in the TCK if it's already covered, if that method is already covered, if it has those proper tests, right? If it doesn't, just, because a TCK test is nothing more than a plain JUnit test annotated with run with Archillion, which is like a JUnit extension to it, right? You add a new shrink wrap deployment, you create a deployment that would somehow resemble what you're trying to do, and do a GitHub pull request. Somebody, either me or somebody from Google side, will have reviewed, like discuss it on the code as you do it normally in GitHub. And most of the stuff, if somebody has a valid case, we always merge it into the TCK, right? And you can see the easiest way to do is, like, you see an example how it's done. You copy paste it, fix it so it resembles your example, your problem, and then just run it against your code. You have instead of describing, trying to describe it in details, in this case, the code tells you more, right? And it will tell us more, and it will show us, okay, let me run your code against, I don't know, I'll run it against CapeDwarf, Google will run it against SDK or AppSpot, and they will see if you have a valid point, right? So it's pretty easy. So the details that I promised, of course, the Datastore, it wouldn't be possible without the InfiniSpan and all that comes together with InfiniSpan. So we do base a lot of code on InfiniSpan. InfiniSpan is a JBoss project, data grid / cache, right? It implements data grid and cache, and we use that a lot. Next slides, there will be a bit more details on how we use it. So for the task queues, we use JMS and Hornet Queue in this case, right, which is the JMS implementation inside Wildfly. Endpoints, we used to sort of generate JAX RS, like a REST easy code, but it turned out it was actually easier for us to basically just tweak the existing endpoints code or a library. The Google's endpoints library, when I looked at it, it fitted nicely with just a few tweaks. So whatever is supported in real App Engine, we support it because we use the same library, but just with a bit of tweaks. So it runs in CapeDwarf as well. And of course, we have a sort of like a support for modules. Of course, we don't have, in the standalone version or the current version we don't have of course, we have to mock the modules. We don't split the app into different instances, but we do support sort of, we try to mock the modules on like here into a proper Google App Engine modules, right? We do try to split it and set up proper things around it and so on. And runtime, which is the Wildfly, of course, it's like a subsystem with deployers, services, and so on. Let's go over each of those in a bit more details. As I said, like for example, you have multiple instances of your Datastore service. Of course, they all connect to the same InfiniSpan cache. InfiniSpan cache, in order to be able to do queries and so on top of Datastore, we morph those Google App Engine queries into InfiniSpan queries. And InfiniSpan query uses Hibernate search, and Hibernate search uses Lucene. In the case of course, if like a standalone, you can tweak it. It goes to the file system-based directory, Lucene, right? But once if you're in a cluster, it uses, there's like a InfiniSpan-based implementation of Lucene directory. So it means InfiniSpan basically uses itself to store the index data, right? And by that, because InfiniSpan, we know it's clusterable, the whole stuff, the whole Lucene indexing is clusterable as well. So you don't have to worry about single point of failure. You just properly tweak the configuration of those. I think we use around 10 different InfiniSpan caches per app. So each app gets 10 different instances of InfiniSpan cache. But that doesn't mean that's like a costly thing. In creating a cache, it's not. We could sort of like being able to use just one cache and namespace it, everything that goes on, but it's easier and nicer to have, for each different thing, have a separate cache. So of course we have one cache for 3 caches for Lucene indexing. We have one cache for Datastore. We have one cache for memcache, one cache for task queues, and so on. A couple of implementation details cached for providing proper locks on top of all the services and so on. But yeah, that's the picture, right? You have InfiniSpan query, Hibernate search, and so on. So about the queue. So in the case of queue, you have app. App does a asynchronous task queue, like a task instance. Of course, task queues are also transactional. In the case of course, and we know that JMS is transactional. For example, if you have a running transaction, for example, in the case, of course, Datastore and task queue transactions are all also, in the case of CapeDwarf, are all based on what Wildfly provides in the way of transaction manager, which is Arjuna transaction manager, or I think it's now called differently. You can always ask Paul. Paul was the one doing that. So what I'm saying is, for example, this stuff is also transactional, right? If transaction fails, the task queue's task won't be actually submitted forward. It wouldn't be used and so on, because the transaction will fail, right? And JMS provides that. It's like basically we turn that task into a JMS message, push it into the JMS, and that actually creates an invocation. And we know the task queues, what they do is they invoke servlets asynchronously back. They asynchronously invoke back servlets in our own apps, right? And that's what we do. We push a message into JMS, and it asynchronously invokes back your app. Also, the nice thing about using a JMS, in that case Hornet Queue, we also get the balancing, right? Hornet Queue does the proper balancing. It somehow knows how to properly balance those messages across different nodes once we're in a cluster. It's like a nice case of reusing JMS technology. As I said, for the modules, we need to properly map Java EE here into Google App Engine modules logic. What we do is we set up a virtual server for each module. That just means that instead of accessing each module gets, of course, its own sort of port. but you have to manually create those ports, manually create those virtual servers. At least that's what we are at the moment. We could, I think, the problem with that was that we couldn't create them on the fly. There wasn't a proper API at the moment, at that time when we were doing this. Could be we need to revisit this, so we could on the fly create virtual servers. That also in the Wildfly means you have to add connectors to the Wildfly subsystem and so on. But yeah, for now I think we have sort of a couple of virtual servers already configured. And if you deploy an ER, it uses those pre-configured virtual servers. So one module would go to 8080, the other one would go to 8180, the next one would go to 8280, and so on, right? We will still have different modules available through the same sort of host, but under different ports, right? This is what also SDK does it, but as far as I remember, they do it like a funky random port thing, right? Where of course AppSpot does it properly with the proper URL and so on. There was like a to-do if there will be more demand for this. Of course, we have JBoss Wildfly has a thing called domain mode, which means you have instead of like a standalone mode, which is what we use at the moment, we have a domain mode, and we could have a custom domain controller which would create host instances, or actually those hosts would create proper application server instances, and each module will get its own application server instance. And of course, different modules, different apps of modules could share those application servers and so on. Just to quickly mention also this, for the testing of this stuff for the modules, of course, once you want to test that properly, you want to sort of, through the tests, you want to see, you want to have, for example, of course, the app, even though there are different modules, if it's a modularized app, they still share the same backend, right? They still share the same data store, task queue, and so on. And for example, when you want to do like a JUnit test, you want to, of course, invoke one test in one module, putting something in the data store, and then grabbing the same data out of it from a different module, right? And you still, of course, because you pushed it into the first module, you want to grab it out. It should be there. And in order to nicely integrate this testing, so it's all clear what the test does, we had to extend the Arquillian protocol with our own modules protocol. So if you're familiar with Arquillian, plain servlet protocol wouldn't do it there. We need an extension to the servlet protocol, and that's the new modules protocol. And that modules protocol is used in the TCK, right? CapeDwarf runtime, as I said in the beginning, it's extending Wildfly. It's like a new subsystem. That's how you extend Wildfly these days. And it's all about deployment unit processors. If you're like an old JBoss user, JBoss deployers, that was like a notion, one of the first notions of JBoss Application Server version 3, and it made the JBoss Application Server quite popular because you were easily able to add your own deployers and extend your JBoss Application Server, right? It wasn't a monolith, it was a extendable application server, and the deployers were that mechanism how you would do it. And that's basically what deployment unit processors are. They are old school deployers. We have sort of 10 plus those deployment unit processor per phase or purpose. For example, the first one recognizes that this is a Google App Engine app, like a CapeDwarf app, creates a marker, and all those next deployers sort of they first look, is it a CapeDwarf app? Okay, then we need to do something. If they're not, and they create different things, for example, setting up the caches, pushing proper web components in, creating proper authorization mechanisms, setting up proper class loading, etc., right? But still, this subsystem, CapeDwarf subsystem, there's almost zero configuration. The only configuration that we have is for the authentication, if you want to have your own custom authentication, and so on. There are a few MSC services. That's the new kernel inside Wildfly, the MSC, and it's fully modular. So, for example, you can when you run your App Engine app, of course, you bundle up your App Engine API jar inside your app, and okay, that gets stripped in the app spot, and I don't know how it's done in the SDK. Probably it's also stripped, but in our case, you can either, if we still recognize the app as an App Engine app, but you don't bundle the App Engine jar, it will still work because we provide a Google App Engine API jar as a module. And we will connect that Google App Engine API module to your app. But if you have the jar inside, it will use that jar. So it means we can sort of, depending on the API compatibility between the versions, we could support different APIs, right? But of course, the implementation and debug is going to always be the latest. But the good part of not bundling the App Engine jar is that the app is smaller, right? Instead of those 20 megs, you don't have to worry about those 20 megs because they will come as a module. Like a work in progress, as I say, it's pretty stable. It's pretty solid, the API. We do PaaS. We have the setup. I have a team series setup of CapeDwarf Test Suite. CapeDwarf Test Suite pulls in the whole TCK plus a bunch of custom tests that live in the in CapeDwarf Blue, like a couple of custom tests. But mostly these days, when we create a test, we directly push it into the TCK and then run it against CapeDwarf as part of the CapeDwarf Test Suite. So since there are no API changes, new or API additions, we also don't have much work, right? But what we're doing now, we're waiting for the new Wildfly 9 release. So we have a proper, I think it's going to be, Alpha 1 was out, but it didn't have the pieces that we needed. So we're waiting for the next release. It's part of the, it should be Wildfly development list, mailing list that knows when it's going to be available. And of course, what it comes with the release that we're waiting for is the improved InfiniSpan 7. Current version is InfiniSpan 6, but InfiniSpan 7 will have quite some improvements that we crave for, right? A couple of those actually came from our intensive usage of InfiniSpan, and in order to accommodate the issues that we found, they had to change some of the API. That's why a version bump, and we are really looking forward to using the InfiniSpan 7, performance-wise and so on. And also, by that, they're going to bump the Hibernate Search version, which uses the newest Lucene. We are using currently 3.6, and I think the latest Hibernate Search is going to use Lucene 4, which also comes with the performance improvements and API improvements and so on. And a bunch of other stuff, some undertow improvements and so on. We also started sort of, I don't know, playing or trying to move into more serious stuff is the sub-project called CapeDwarf Manage. It means that you'll be able to use Google App Engine API directly in Wildfly. That doesn't mean there's going to be the whole implementation behind it. It just means that you can use Wildfly as a managed custom runtime already inside Google App Engine, right? That's the new stuff, managed custom runtimes that they are promoting. And this project CapeDwarf Manage creates a proper Docker image, which sort of adds the integration code into each of the requests, setting up proper context or environment so that Google App Engine calls do go properly against the Google backend, right? If you will just directly call some of the methods from, for example, if you create like a public static one main method and would try to use Google App Engine API from that as your custom runtime, it wouldn't work. You need some sort of code that sets up a proper environment, proper context around each invocation of the API, and that's what this project provides. It's also all on GitHub. It's in the early phases, but it already does things as the stuff that they also provide as a Google managed runtime, because as I mentioned, we have those G Cloud supported tests, and what I'm doing, I'm running TCK tests against this CapeDwarf manage, and we pass the same rate of tests as App Engine managed runtime, right? So, but yeah, now once we're done, just go out, try it out. As I said, it's really simple. Just download the latest CapeDwarf release out of our downloads, unzip it into a CapeDwarf home, wherever we want it, and run. It's like a CapeDwarf SH for Unix, Linux, Mac based, and you have of course CapeDwarf.bat for Windows, right? It does. There are, for example, why the extra script, right? Because we have our own, instead of Wildfire has these profiles like a standalone.xml, standalone -ha XML, full HA XML, and so on. And we of course we have our own custom standalone XML file, which already adds those proper caches, authentication stuff, virtual servers, etc., and so on. Hornet queue to handle the task queues and so on. And this script just hides that, plus some small bytecode tweak that we need to do in order some of the stuff to work. And then what you do is like any normal app, just deploy it via Wildfly management or drop it into Wildfly deployments directory, and Wildfly will pick it up and it will deploy it, right? So let me just quickly show what what you can expect, how easy it is. Just go out. I hope you can see it. I'm here in the latest CapeDwarf 2.0 CR5 release directory, and just go here. CapeDwarf message, that's it. And it will boot up this. Okay, that red stuff is some Hornet queue thing that fails on Mac, but it's not an error. It's okay, it is an error, but it doesn't do any harm. Of course, here we are ready now to serve your Google App Engine apps. Let me clear this up. What I did, I went into a App Engine SDK, which comes with the demos, and I bundle up a root var from the Hello OREM 2 example. Right? I'm going to deploy it. I'm just going to copy this over to the running instance. Let me move here, and you can see, right? So it picked it up, it scans, it now adds all those different deployers kick in, and we have a running app. So just move over here, local host. That's the simple app, right? We just Ljubljana to Munich, right? Where I usually fly. If I want to get somewhere, add flight. That's it. Munich, San Francisco, add flight. And this runs a JPA app. It's like a data nucleus JPA that goes against the Google App Engine API, right? We can switch to JDO because data nucleus supports both, and that's it. So we can drill down into and delete the file, delete, and that's it. So, right? Pretty easy. Of course, sometimes one of the, for example, let me go back to the slides. Most of the issues, of course, that we encounter is that, of course, App Engine as it is pretty bare bones, right? If you don't have a library there, it doesn't work. Where, of course, Wildfly comes because it's like a Java EE compliant Application Server, right? It comes with a bunch of stuff already in it, with all the EE stuff, REST, CDI, JPA, and so on. We do try to do our best to sort of exclude or disable most of the stuff that could interfere. But usually the issues that we see is, of course, that people have their own original app, and they bundle all the stuff, they cram all the stuff into that bar, right? With the REST implementation, with the CDI implementation, with, I don't know, whatever implementation, JPA implementation, and so on. Of course, in the case of CapeDwarf, some of the stuff is already available on the class pad and could interfere, right? So that's most of the issues that we see, right? And for example, we have REST Easy coming out of the box supported, and it scans and it finds your REST endpoints, where you also, when in the app, you also have Jersey, right? And it doesn't play nice and so on. So those are the issues usually. So that's what you need to be aware. But I think, but the thing is that then you clean up and you move all those duplicated EE implementations out of your var, and it should work, right? In most cases, that's how people fix it, and it works. So far, we didn't have a deployment that wouldn't be able to make it work, properly deploy at the end. Okay, so yeah, I'm done. So that's the information. You can see it. We have a JBoss org forums for CapeDwarf users. Probably the easiest way to do it, just post your issues over there. So for everybody can see it, and for people from CapeDwarf team or JBoss team and so on that are familiar with the stuff, can see it and comment on it. I'm always, during the day, I'm available, or even during the evening when I do some work, I'm available on #CapeDwarf on Freenode IRC. For more information, we try to put as much information on the CapeDwarf.org website, and that's my email. If you want to have some questions, if you want to go public or whatever. I do appreciate for any public stuff you use the forums, or I don't know, even on the Stack Overflow and so on. But of course, email is always there, and I try to answer as much as possible. So yeah, so that's it from my side.
That's great. Thank you very much, Alex. It was very interesting. So I'll just hand over to the room. Is there any questions from anybody?
Just wondering if there's been any comparisons between using Google App Engine backend against, like, if there's, how they compare against using Wildfire.
Do you mean like the performance, or?
Yeah.
Can you hear us, Alex?
Sort of, not 100%.
Okay, so I think the question was, has there been any comparisons, maybe performance or other ways of measuring, to compare the CapeDwarf to the Google App Engine's own implementation?
Oh yeah, okay. Performance-wise, that's what I'm looking forward for in Finispan 7. What we found, for example, for the small, of course, we're never gonna be able to match the AppSpot implementation, right? You have the huge Google backend at the back, and of course, as much as you pay, you get more resources and so on. So on that side, of course, not completely, but on our side, for example, on the SDK against SDK, we do compare a lot better, I think, even performance-wise, because the SDK itself is a mock, right? So you couldn't even use that in any. Okay, you can use it for simple testing, but for example, the people that I talk to, the users that I talk to, what they do is they always go with CapeDwarf for testing, right? Some of them even use it in production and so on, but they're ditching SDK in favor of CapeDwarf for local stuff, right? And because it's easier to test, it performs better, it's more reliable, and so on. Okay, performance-wise, I must admit, like I said, we did find some of the issues with Finispan 6, and unfortunately, it was a issue that couldn't be resolved with sort of like a simple code fix. It was again like a combination of J groups plus InfiniSpan, and this was dealt in InfiniSpan 7. But first found issues with the backend InfiniSpan uses sort of like a store. It could be like a file store to write down the data when it spills over, or when you shut down. Of course, it needs to persist the data, and it does it into a store. And you can, by default, we have a file store configured, but you can of course change to any store that InfiniSpan provides, right? I think they have a support for database and different things and so on, right? And that turned out to be, that was first of the bottlenecks, and then in the TCK we have a sort of like a simple benchmark test where we handle around 10,000 entities, and unfortunately we found like I said, we found a performance hit that when handling lots of entities in the same transaction. But for, I don't know, a couple of entities, it's pretty fast. But like, as I said, we don't try to reinvent the wheel. It's the InfiniSpan that provides this, and we just try to use it as best as possible. So, and InfiniSpan comes in production form as JBoss data grid, right, as a product, right, and that's the anchor that's used. So, also on the Red Hat side, we try to put a lot of effort into making sure that InfiniSpan and its product is best as possible. So, and it will eventually, the code that goes in there will eventually come into GitHub as well. Did that answer your question?
I think so, yes. Yeah. So my understanding is that at the moment, people use CapeDwarf for development, but then they deploy to Google App Engine for production.
Yes. For example, it depends on, of course, it depends on the nature of your app. For example, I myself have with my friends, we have some mobile app that we poke around. Okay, we didn't make any money on it, but we do. It's like an app that runs daily, couple of, I don't know, 1,000 requests, and it's all based on CapeDwarf, and it runs nicely. Like 2-node cluster works. No, but the thing, the app is not super burdened, right? There's not a lot of. It's still a couple of 1,000 requests, but that's it. And the stuff that it does, it handles a couple of entities per request, and it's pretty fast.
Okay. So is what's kind of the long-term plans with CapeDwarf? Is there plans to kind of on OpenShift to have like a platform as a service like Google App Engine, so people can just go and deploy their applications to either OpenShift or Google App Engine without having to manage the cartridge themselves, or is there some other plans going forward?
Yeah, I think the best thing that we can do is probably provide as good as possible support on OpenShift. We did have a cartridge with OpenShift version 2, and it did. There are people using it and so on, but at one point, resources-wise, and even with OpenShift changing so fastly, we weren't able to maintain it 100%. Luckily, this changed with the OpenShift version 3. I'm actually part of this group that moves JBoss or middleware stuff onto OpenShift. So for me, this is just going to be another like a task I'm actually looking forward to, and I know the details from both sides, and I'll push CapeDwarf onto OpenShift as best as possible, because I'm involved in it and I know both of the sides pretty well. So that's the goal with making it more like into product side. We don't have any of those plans yet, or not inside.
Okay. Is it possible to share your camera rather than the?
Oh yeah.
We can see you.
Yeah, forgot.
It's okay.
Okay.
Hello. So I've got another question for you as well. So it's really great that Google has been getting involved, and they seem very keen in helping out. I'm just interested, have you got any insight into what Google's motives are here, why they're interested?
Of course, one of the things I think they did like to get the hands-on testing, right? To see testing from an independent perspective on how we do it. So they're quite pleased with that. Of course, from the business side, of course, we're not really a threat, right? And the thing is that they also always say, and once they come out, once we did the problem, for example, a year back, we were part of the Google I/O. They promote us as well from their side, and they promoted us. The biggest thing that they said was like no vendor lock-in, right? That was what they were sort of proud of. That you have of course, you have a project called AppScale that comes from the University of South California or something like that, I think, and Santa Barbara. And but yeah, their approach is different. They reuse the SDK code and tweak it a bit, like actually tweak it a lot. So that's not. But in our case, we started from scratch, right? We actually have from ground up. We basically just rely on the interfaces, and we have the whole implementation in the back. So we do get a lot more knowledge to it on how things works and what our problems were and so on. It's always good to have a sort of, at least me and Marco, who's part of the team, to tell them that something, for example, something's wrong or something like that. I think those biggest motives are, right?
Yeah.
And for example, when they're moving with App Engine version 2, they're moving into the managed custom runtimes, so they will have less and less restrictions on the API usage. And of course, that's all new, right? And even from then, for example, if you want to provide, for example, that case of managed custom runtimes, they try to do it best as they can, but they don't have and they have me as a critic of their API of their code, right? For example, when I was setting up like a CapeDwarf managed project is a good example of why they like to have us near as possible. Because I went out, I implemented the stuff, I saw what was wrong. For example, it took too much effort for a normal developer with, for example, I have a knowledge of App Engine for the last 2-3 years when I was doing the CapeDwarf, so I have the inside details of the whole App Engine API, what it takes to make it work, right? But if you're somebody that wants to provide a custom runtime for your company, whatever, you don't have the knowledge to be able to wrap things in a nice, proper way around the applications, right? And that's what we go back and forth communicating how that should look like. Should be like a proper SPI or API to do that, right? So that's, I think, the motives are. So you have an outside critic that knows the environment quite well.
Okay, yeah, that makes sense. I also wonder if it's a similar motives that they've got around Kubernetes, in that the easier it is for people to migrate from one platform to another, the easier it is for people to essentially gravitate towards Google. So if they think, if they think that they can do a better job than us, then they can, it'll be easier for them to migrate our customers over to their platform.
Yeah, and then you have, like I said, you have Red Hat or like a JBoss brand that's well known, and you have people that look at this. Is what I have. I'm like a web developer. I can start off with I'm a well-known. Okay, I'm aware of. I've been using JBoss AS or Wildfly for a long time. And this is Google App Engine. I just don't want to switch immediately. And in the case of Wildfly, at least you can mix and match things for a long time. You can use the EGBs and all the stuff that Wildfly provides, and you still slowly port your code over to the Google App Engine API, right? Of course, and you can slowly migrate. It doesn't mean you have to switch it overnight. And once you're done, you can move it over to the AppSpec or something like that. So that's another aspect of it. And with the G Cloud, of course, another thing that they want, for example, if you think about it, you don't have any proper open source app servers out there as Wildfly, right? Glassfish is not supported anymore, and anything else is just not the level that you want it to be. And if you have gcloud and you have managed runtime, you have Wildfly that provides you proper Java EE on Google Cloud.
No, that makes sense. Is there anybody else that's implementing this SDK, or is it just Google and Red Hat at the moment?
You mean the API or the?
Yeah, so the API, yes.
As I said, it's like an AppScale project.
Oh right, sorry. So what's AppScale? Who's AppScale?
AppScale, I think. Okay, they created like a former students. It was part of their I don't know, PhD or something like that, and they created a company around AppScale. And for example, we just support Java stuff, and they support all the environments, because, like I said, they reuse. I think they reuse SDK stuff, and they tweak it at the back, right? So a bit differently, where we actually implement all the interfaces.
Okay, yeah, that makes sense. So, any more questions in the room? No. Okay, well, that's really great. Thank you very much, Alex. We'll say goodbye now.
Pleasure to.
Thank you very much. Cheers. All right. Bye.